Hello, my name is Rahik Al Huslan, and today I will speak about applications and tools in data science. Here we have some facts. Did you know that we create 2.5 quintillion bytes of data every day? That's enough to fill 10 million Blu-ray discs daily. The Boeing plane is generating 20 terabytes of data per hour during flight, and this massive data production highlights the importance of tools to manage and analyze effectively. So what is data science? Data science is a blend of statistics, computing, and domain expertise. Its primary goal is to extract meaningful insights from raw data. Tools uh, are crucial in this process. They make data exploration, analyzing, and sharing more accessible, from the simple spreadsheets to advanced AI solutions. So sometimes the simplest tools are the most effective. We have spreadsheets like like the most used and understood one are the Excel, Google Sheets. They are easy to filter, sort, and browse data there, giving common ground for clients and analysis. And the key features for them is the compatibility, the CSV famous format, and they're easy to share and export. SQL, or the structured query language, is essential for working with large databases. It allows us to select, combine, and manipulate data uh, stored in relational database with just a few commands. The SQL can handle the majority of tasks um, analysts need. Here we have uh, dedicated visualization tools. Tools like Power BI, Tableau, and Click. They are designed for data visualization. They make it easy to explore data um, and integrate data from multiple sources and sharing insights through visual storytellings. Um, Not everyone needs to code, needs to know coding to analyze data. So there's tools like SPSS, which is used by academicians a lot, and it's make the data analysis accessible for non-coders with intuitive interfaces for tasks like the hypothesis testing and descriptive statistics. Programming languages like Python and are essential for data scientists. Python versatility and our statistical capabilities make them popular sources. L- Libraries like TensorFlow, scikit-learn, they extend their functionality for advanced machine learning tasks. So why scikit-learn is the go tool for the machine learning? Um, in Python, of course. It simplifies complex tasks like regression, classification, clustering, and it's making it ideal for data mining and analyzing. Its intuitive design makes it accessible for beginners and experts at the same time. Um, Scikit-learn excels in various tasks. For example, classification is predicting whether an email is spam or not. Regression, example of that, estimating house prices based on features. Clustering, example of that is grouping similar customer for targeted marketing. Um, and it can be used for different things, so it's kind of must have tool. So once you know what kind of problem that we are working on, like it's clustering, is it like recognition, we will need to split the data into different sets, and with one for our machine learning algorithm to learn and the training set, and another for the testing, and then we choose a machine learning model and evaluate whether or not this model has learned anything. And again, the scikit-learn offers Python implementation for doing all of this kind of task, from preparing the data to modeling the data, and it's saving us from having to build them from zero, while also being applicable to multiple areas focused. Here we have the essential toolkit for AI machine learning professionals. We have here uh, data analyzing tool. We can see Matplotlib, we can see NumPy, Pandas. We see the data science tool Anaconda, Jupyter. We see the machine learning tools like TensorFlow. We see the scikit-learn, and so on and so forth. Um, Emergent tools, the AutoML, it's a approach that simplifies and automates the entire machine learning workflow. So instead of manually performing complex tasks like selecting the best model or fine tuning hyper parameters, auto ML is tools handle this process automatically. Think of it as having personal assistant for your machine learning project. It's taking care all of the um, repetitive and time consuming parts so you can focus on the big picture, solving the problem. We have here some examples. Open source solutions like auto sklearn is built on the scikit-learn library. It's preferred for classical machine learning tasks like recognitions and classification. We have also auto Keras. It's designed for the deep learning. It's work on top of Keras and TensorFlow. It's automatically built and train the neural networks for tasks like image recognition and text analysis. We have also H2O AutoML, and it's provide an end-to-end solution for both the machine learning and the deep learning, and it's offer scalability for large data sets and integrates well with cloud environments. um, we have also machine learning as a service, uh, like Azure ML, like Amazon SageMaker. They offer advanced like machine learning capabilities in the cloud. They're scalable, cost effective, and feature drag and drop interfaces for rapid development. Example include the text to speech and chatbot creation. Here we have the data analytics workflow in action. So how does a company like Netflix, for example, recommend shows in the real time? They leverage the pipelines just like this, combining data, um, ingestion, processing, and analyzing. How they recommend the shows in real time. First, we have the first step, the capture. The first step in the data ingestion is getting the data into the system. For example, Netflix they capture million of user interactions per second, such as what the shows people watch, when they browse, or how they often rewatch. Uh, we have also the process. So once the data is captured, it needs to be processed either in real time batches. So we have tools like Cloud Data Flow and Cloud Data Broke. They handle this by cleaning organization and aggregating information. So they use it to combine data from global services, applying filters to remove unnecessary data and standardize the forms from seamless. We have then the next step, which is stored. The versus data is then stored into repositories like cloud storage for unstructured data, video logs, or BigQuery for structured databases like user watch histories. And it's ensured for Netflix to access billion of rows of data instantly. Uh, then we have the analyze step, and uh, this comes after the store, and it's the magic of analyze tools like BigQuery. It's helped Netflix to uncover patterns and insight of what generates user prefer, what times they're most active, or which shows they're likely to watch next. Finally, these insights are turned into actions with platforms like TensorFlow and Locker. So Netflix applied the machine learning algorithm to predict what a user will want to watch next. Here we will have my last slide, which is about the uses areas of data science. Finance and banking applications. We have the fraud detection using anomaly detection models. We have risk assessment and credit scoring. We have algorithm trading and investment prediction. And this have a lot of impact. It's improved the financial security and customer trust, efficient and accurate financial operations. I'm sorry. We have healthcare applications in healthcare, like prediction for disease diagnosis like diabetes, cancer, and so on. We have also retail and e-commerce, for example, recommendation engines for Amazon and Netflix. We have also transportation and logistics application in transportation, like Uber, like Lyft, and the maintenance for the vehicle and infrastructure automates vehicles powered by data and AI, and it has a great impact, which is reduce the operational cost and improve the efficiency, safer and most reliable transportation systems. Thank you so much.